What is the difference between accuracy and precision? Really simply, the best way to describe it is using archery, okay? In the top left, we see something that has low accuracy and low precision, which makes sense, all right? We are not really hitting the target, and our arrows are not really clumping together, okay? We're not very consistent with our shots, okay? In the next example, to the right, we have something that has high precision and low accuracy. So what's changed between, target 1 and target 2? I'll call this target 3, and this target 4. Well, in target 2, now we're a lot more consistent with our shots. We're getting shots that are tightly clumped together. The problem is we are not aiming at the right place. We should be aiming at the bullseye. The bullseye being the sort of truthful value in your experiments, the value you want to figure out. This value could be, what's the actual weight of this, block of wood, okay? Let's say there's a block of wood, and we want to find the actual weight of this block of wood. That could be your bullseye, okay? And let's say you have a scale that, accurate is very precise, but because as you're weighing the block of wood, you also happen to have a person standing on the scale, which causes every value you take to be, an extra 60 kilograms, you're inaccurate. And the reason you're inaccurate is because this block of wood might be 100 kilograms, but every time you get a reading from the scale, you're getting something like 160 kilograms, okay? So it's 60 kilograms off, but you're getting tightly clumped values. So you're getting 161 kilograms, 162 kilograms, 159 kilograms. Your values are consistent, such as in this case, but it's not accurate at all because the actual weight of the wood is 100 kilograms. You're getting values of 160 kilograms. So it's not accurate, but it is consistent, and because it's consistent, it is precise. Let's look at target number 3. It's very accurate, but not very precise. So we can see that we're aiming in the right place, but we are not very consistent. Okay, our bow is pointed nicely at the bullseye, but our hand is shaking. We are not very confident, or some other factors causes it to be not very precise, not very consistent. Finally, you have the Olympic level archer at target number 4. He or she is accurate and precise. So he or she is aiming at the right place, and the bow is also very precise. So he or she is also very consistent. So those really the difference between accuracy and precision. If you wanted to show it using the block of wood and scale example, if you had low accuracy and low precision, you would have a very cruddy scale and the block of wood with the person standing on it. Okay, this is a very cruddy scale. So let's say the scale only reads up to 1 sig fig. Okay, it can only be, it's 100 kilograms, or it's 200 kilograms, or it's 0 kilograms. Okay, that's not very consistent. That's not very good for a measurement. Okay, and on top of that, all your values are going to be slightly off because you have that extra 60 kilograms sitting on the scale. In this example, in the second target, we also already talked about this. You have the block of wood, and you have a very good scale. The scale is very good. You get a very good reading, but there's a person standing on it. That's an extra 60 kilograms. When the actual truthful value of this wood block is 100 kilograms, this 100 kilograms kind of represents the red dot that we're trying to aim for. We're getting everything 60 kilograms extra. So this could be like that plus 60 kilograms, okay? However, every time we read it, we get values that are like 161, 159. So values that are very close together, very clumped together, very consistent, but not accurate. Finally, in target number 3, we might have a cruddy scale that might read up to only 1 sig fig. So you might only have 0 kilograms, 100 kilograms, but it's always going to aim at the correct value, sort of. So there's no person standing on the scale messing up results. It's just a block of wood there. Okay, the only problem is the scale is not very precise. So because it's not precise, you might only have 1 sig fig value of answers. So that's going to give you a huge range of values like you see over here, but those range of values will will sort of average out to the actual value, which is 100 kilograms. If you took readings, 200 times, 2,000 times, and you average them all out, they would get a reading of 100 kilograms. Okay. And finally, high accuracy, high precision. No one's standing on the scale, so no one's messing up the results, and you have a very good scale. So it will consistently read 100.3 kilograms, or 100.2 kilograms, or 99.98 kilograms, or something like that. Okay, your values are consistent, and they will have high accuracy because you are measuring the truthful value of what the block of wood is. In this example with low accuracy, you're not measuring the truthful value of wood. You're measuring the truthful value of wood plus an extra 60 kilograms, which is making it inaccurate. So that's the difference between accuracy and precision.